Hello students, welcome back to the YouTube channel Education Adda, making maths easy for you. In this video, we will discuss the important formulas that we are using in exercise 12.1 and their derivations and how they can be used there. We will define everything one by one in a simple way to you. So let us start the video. So first of all, let's start from the very basic, the area of the circle. As you all know that the area of the circle is pi r square, where r is the radius, so area is pi r square. Circumference of the circle, that is the boundary of the circle, 2 pi r. You have already read about in the previous classes. Arc of the circle, you have already familiar about the arc of the circle, that what an arc of circle is. It is the length of the circle between the 2 points along the circumference lying on the boundary. If there are any 2 points lying on the boundary of the circle, then the distance between them along the circumference is called the arc of the circle. Depending upon the portion covered, if it is smaller, then it is minor arc. If it is larger point area, then it is major arc. It is denoted by like this: AB, overhead by an arc. Here the arc AB is minor and the arc BA is the major arc. And the length of the arc, by the formula, the length of the arc is theta upon 360 into 2 pi r. Where what is theta? Theta is the angle between the two radii drawn at the end points of the length of the arc. If the arc is starting from point A and ending at point B, then the angle between the two radius drawn at the point B and A is theta, which we call theta as a sector angle. It is also known as central angle or the sector angle, which is the angle subtended by two radii at the center. So this is the formula for length of the arc, theta upon 360 into 2 pi r. Then the next one is sector of arc. What is the sector of a circle? Sector of circle. So sector of the circle, it is the area, like here I am showing you by shading by the red marker. This area which is enclosed between the two radius and the arc, like this area, this is called the sector of the circle. This is called the sector. Here I have written point x and y here to differentiate between the minor and the major sector, as it is the minimum area because the angle is less than 80. Whenever the central angle becomes greater than 180, then the sector will become the major sector. But now, since it is less than 180, so it is minor. So AOBX, this is the minor sector, and AOBY, that is this one is, which I am shading with the black one, this one is the minor sector. This one is the minor sector. And the area of the sectors is theta by 360 into pi r square. So these are the formulas that we have to use in the initial phase of this exercise 12.2, which are length of arc, area of sector. One is theta by 360 into 2 pi r, one is theta by 360 into pi r square. Now let us move ahead towards the next important terms, which were segment, which is the segment of a circle. How can we define the segment of a circle? We will have the definition of the segment of the circle and the proof of area of the segment of the circle. So what is the segment of a circle? This is the fifth definition. Segment of a circle. So let us have a circle there first. So this is the circle which we have drawn with the help of a simple ring. Then what is the sector? Suppose this is the arc AB. Then the chord drawn at the endpoints of the arc AB. So what is the sector? Actually the sector of a circle, the segment of a circle is what? It is the area. It is the area enclosed between the chord and the corresponding arc of the circle. So how can we define the segment of a circle? Segment of a circle can be defined as the area enclosed between the chord of circle and corresponding corresponding arc of the circle. So students, how we can find the area of the segment? Listen, we also have the major segment, like here AB is the chord between since this is the minor arc, so this is the minor segment and this is the major segment. Okay, in a circle, the maximum area between the chord and the minimum area between the chord, this is major and this is minor. So how we can find the area of segment? So there is a simple formula that we can use to find the area of the segment. Let us show how we can do that. Suppose if there is a chord, there is a circle and O is the center of the circle. There is a circle with the center O and AB is the chord. So this is the segment. It means we have to find this one area. This AB, area of the segment, this one, we have to find this one area. And this one, these are the radii drawn at the endpoints. So here we have this AOB, this is the sector AOB. And if from this sector we subtract this triangle, then we left with the area this. It means area of segment is equal to area of sector minus area of triangle inscribed in the sector. So किसी भी सेगमेंट का एरिया कैसे फाइंड आउट किया जा सकता है? किसी भी सर्कल के सेक्टर में से अगर हम ट्राइंगल को सब्ट्रैक्ट करें. नाउ एरिया ऑफ सेक्टर कैन बी फाइंड बाय द सिंपल फॉर्मूला थीटा बाय 360 into pi r square. Area of triangle have the formulas 1/2 into base into height. But what if height is not given? If height is not given, here we have three cases. Let us study each and every case one by one. So case 1, if the sector angle, like this is your circle 1, circle 2, circle 1 and circle 2 with the radius, suppose the radius would be r, the radius is r, a. If this angle is given 90 degree, that is theta is 90. So simply if this is 90, or then obviously it would be perpendicular. Both of these lines should be perpendicular. So height is given. So area of segment is equal to area of sector AOPX minus, let the point x here, area of triangle AOP. So area of sector theta by 360 into pi r square minus area of triangle half into base into height. Since in this triangle base and height both are radius, because both are 90 degrees, so both are radius. So this is theta by 360 into pi r square minus 1/2 into r into r. So this is theta by 360 minus r square by 2. Minus r square by 2 simply when this angle is 90. This is case 1. Now case 2, if this angle is 60, suppose the angle between the radius is 60 degree. Listen students, if this is 60, then AOB are also equal. So this and these angles would also be equal. So by angle sum property, these two angles would also be 60. So it becomes an equilateral triangle. So now area of segment, this is first case. Area of segment theta by 360 into pi r square minus area of triangle AOB. Since this is equilateral triangle, so its area would be under root 3 by 4 side. Since all the sides are equal, root 3 by 4, it is r square. Since it is an equilateral triangle, then obviously all the sides would be equal. This is r, then this would also be r. So it is under root 3 by 4 r square. So this is formula number 1 to find the area of segment, that theta by 360 into pi r square. Sorry for this. This is theta by 360 into pi r square minus r square by 2. And this is theta by 360 into pi r square minus under root 3 by 4 r into r base into side ka square. Under root 3 by 4 side square. But when this angle is not 90, this is not 60, it means the angle is other than 60. Then neither the equilateral triangle area should be used, nor the half into base into height should be used. Then we have to find out the base and the height. So let's go for this, that one, what we have to do in that case. Like this. Let us again have a circle there. Let's have a bigger circle there. Suppose we are given the chord of the circle. We are given the chord of the circle, and this is the center of the circle. Let this angle, complete angle be theta. This complete angle be, that is angle AOB. We are given as theta. Not 60, not 90. So we have to find the area of sector, area of segment, sorry. So area of segment, as we know, can be given by area of sector AOBX, let the point X be there, minus area of triangle AOP. So here's area of sector, this is the radius. Sector can be easily found by using theta by 360 into pi r square. But we have to find the area of triangle. Here we are given theta. We cannot use 1 by 2 into base into height unless height is not given. Even we cannot use root 3 by 4 side square, even since it is not given 60. So this is not an equilateral triangle. So for this we can have to draw a perpendicular. We have drawn OM perpendicular AB. OM perpendicular AB. Since OM is perpendicular, then this would be 90. This would be 90. That is angle 1, 2 is equal to equal. OA, OB are also equal. Radii of same circle. OM is equal. Since common to both. So triangle AMO, BMO would be congruent by what? RHS rule. If triangles are congruent, then these angles would be equal by CP, CT. So this complete angle AOB is theta. So angle AOM, BOM, it's half, so they would be theta by 2. Theta by 2. Now, also perpendicular from the chord, perpendicular from the center bisects the chord. So AB is equal to 2 times AM. Now, in right triangle, OMA we have to find what? AM. Suppose we have to find AM. Since we have to find AM, we have to take OM as numerator, as we have discussed in heights and distances, that the quantity which we have to find, side which we have to find, we have to take it as a numerator. So we have taken AM as numerator, and the side which we are given, since we are given only radius here, OA as radius. So theta by 2, for theta by 2, AM side opposite to theta by 2, it is perpendicular, and OA opposite to 90, it is hypotenuse, it is perpendicular upon hypotenuse, that is sine of theta by 2, sine of theta by 2, perpendicular upon hypotenuse. It gives AM is equal to OA into sine of theta by 2. So AM is OA is radius, R times sine theta by 2. Clear? Now in the same way, if we go in the triangle OMB and find OM, or in the same triangle, from the same triangle we can also find OM. If we have to find OM, we have to place OM as numerator and OA as we are given as denominator. So this is the side adjoining the angle and the 90 degree, that is base, upon 90, opposite to 90, that is hypotenuse. This is cos of theta by 2. So OM is equal to R times cos theta by 2, because when O is multiplied here, it is R times cos of theta by 2. So area of segment, therefore area of segment which we have to find, area of sector since this is radius, theta by 360 into pi r square, radius is r square, minus area of triangle. Now area of triangle now we can find by using the base AB and height OM, minus half into AB into OM. From this equation the value of AB is 2 times AM. So this is theta by 360 into pi r square minus 1 by 2 AB, 2 times AM into OM. These two get cancelled out. So we left with theta by 360 into pi r square minus AM. From there AM is r times sine theta by 2 and OM is r times cos theta by 2. R sine theta by 2 into r cos theta by 2. R into r square, theta by 360 pi r square minus r square sine theta by 2 cos theta by 2. We can also take r square common from here. The formula so we obtained is r square into theta by 360 minus sine theta by 2 cos theta by 2. So this is the area of segment when this angle is not given 60, not given 90. If it is given 60, then theta by 360 pi r square minus under root 3 by 4 side square. If it is given 90, then theta by 360 into pi r square minus half into base into height. But if it is not given 60, not 90, so we can use this formula, r square into theta by 360 minus sine of theta by 2 cos of theta by 2, where theta is the central angle that we have given. So this is the formula that we have to use in this exercise. So have a clear view of video, make your understandings clear. In case of any doubts, you can contact or comment in the comment section. Thanks. Have a nice day.